Hello, and welcome to Lines, Planes, and Polyhedra Part 1. For a quick review, remember that there are three undefined terms in geometry. There are points, lines, and planes. A point is just a location in space. It can't be defined. A line is all the points along a straight, unbroken path that extends forever in both directions. Okay, and then a plane is a flat surface that extends forever in all directions, right? So these are our three undefined terms. There are three types of lines on 3D figures. Two of these lines are contained in a plane. Okay, so first of all, we have parallel lines, and these are lines that are parallel to each other. So for example, M and N are parallel. They will never intersect. All right, and we look at this when I was talking about they can be contained in a plane. M and N are both contained by the top plane, right? Those are both lines on the top plane. Intersecting lines are exactly that. They're lines that intersect, okay? So, for example, here, M and N intersect right here. So these are intersecting lines. And again, these can also be contained by a plane. If we look at it, they're contained by this left plane, right? The left face. Skew lines are lines that are neither parallel nor intersect. All right, so if we look at M, right, it's going this way, N is going up and down. These lines will never intersect, but they are also not parallel. And if you look, these two lines are not on the same plane. So there isn't any one plane that contains both of these lines. So we call those skew lines. Okay, so here we're going to refer to this rectangular prism, okay? How many pairs of parallel faces does the figure contain, okay? So a pair, right, is two. So if we look, parallel faces is the same as parallel planes, right? So it's going to be four areas that we're looking at here. So let's look at this bottom, A, B, C, D. Okay, A, B, C, D is parallel to E, F, G, H. So that's one pair of parallel faces. Okay, then we also have A, D, H, E, which is parallel to B, C, G, F. So that's another pair of parallel faces. Okay, then we also have the front face, A, B, F, E, that is parallel to DCGH. So there are three pairs of parallel faces, okay? And well, we've actually named these already, but I'll go ahead and write them down for you, okay? So for B, we have A, B, C, D, right? That's the bottom face is parallel to E, F, G, H. Okay, so okay, that was our top and our bottom. Now we're going to look at left and right. ADHE is parallel to BCGF. Okay, and now we're going to look at our front and back. ABFE is parallel to DCGH. Okay, now C says name an edge that is parallel to edge DC. Okay, so right here, but lies on a different face. Okay, so here we have DC. Now we know that AB is parallel, but look, it lies on that same face. They both are contained in this plane. So we have to pick something else. We can't pick HG because they share this plane right here. So a line that is parallel to DC but lies on a different face would be EF. Okay. Edge HD and edge blank are skew edges. There are four correct answers. Name any one. Okay, so here we have HD. So remember, skew lines are neither parallel nor intersect. Okay, so we could say that edge FG is one. Okay, we're going to go ahead and name all of them that we can here. So BC would be another one. okay? Because these, right, anything that's going to be parallel to that. Now, we also have EF, okay? That's also going to be a skew line. And then we have AB. So those are our 4 different skew lines. Okay, a half plane. As shown in this figure, any line that lies in a plane separates the plane into 2 half planes, all right? A half plane just consists of all the points on one side of a plane. Okay, so it's just, here we have this whole plane, this line that goes across it divides it into 2 half planes. Okay, when we're talking about half planes, dihedral angle is going to come up a lot, okay? A dihedral angle is an angle formed by 2 non-coplanar, okay? Non-coplanar means they don't lie in the same plane, okay? So non-coplanar half planes and their line of intersection, okay? So if we look right here, our line of intersection is AD because this quadrilateral ADIJ forms the dihedral angle with ABCD. Okay, so this is our line of intersection. Okay, and the reason we call this a half plane is just think of it as ABCD, right? It's going to extend out this way, right? This plane, and then ADIJ is going to continue out this way as well. So this line is what is our line of intersection. So these are where these 2 planes intersect. So for a dihedral angle, we want to figure out which angle has the same measure as the dihedral angle formed by rectangle ADIJ and rectangle ABCD. So if we go back here, okay, what I'm wanting to find is what angle is going to tell me what angle this forms, okay? And if you look right here, JAB, all right, this angle right here is going to tell me what, oops, don't want to end that. JAB, okay, angle JAB is going to tell me what the angle is right there, okay? And or you could also say that angle IDC as well, okay? Either one of those angles, if we were told what either one of those angles are, we would know the measure of this whole dihedral angle. And that is the end of lines, planes, and polyhedra, part 1.